Assalamu alaikum and welcome to lecture 7 of computer organization course, and this lecture will be the first part of memory. First, what's the memory? Memory is storage place for holding data. So any media, any storage media is called a memory. And the data that can be stored in the memory could be system software like operating system or device drivers, or application software like word processing, spreadsheet, etc., or any other files, whether it's text file or sound or video. And the memory, computer memory, has four forms. So it is either internal memory, means it's inside the computer, or cache memory or registers, or external memory or secondary memory that could be attached to the computer from outside. There are some characteristics for the memory system, like the location, and location means whether the memory is internal or external to the computer. So the main memory is internal memory. The registers are internal to the processor or CPU, and the cache memory is internal memory, and we have the external memories. That means any memory that can be connected from outside to the computer through the input-output controllers. The second characteristic is the capacity. Capacity means the size. So how much data, how much bytes, how many bytes the memory can store, bytes or multiple of bytes, kilobytes and megabytes, gigabytes, etc. The third characteristic is the unit of transfer. Means what is the unit the data can be sent or received from the memory. So the unit could be, for example, computer word or blocks or records, etc. Now the memory we can also has different forms based on the material, manufactured material, or the material made of. So we have semiconductor memory, and this semiconductor memory is almost a silicon memory. Then the magnetic service memory, which is made from magnetic, or at least the service is magnetic. And the third is the optical memory, and the fourth is magnetio-optical. It's mixed between magnetic and optical. Another characteristics of the memory are whether the memory is volatile or non-volatile. Volatile means it will lose its content if the power is switched off, and non-volatile, it will keeps or remains the data even without power. So all the magnetic service memories are non-volatile, means it keeps the data even without power. And for the semiconductor memory, could be either volatile or non-volatile. Non-erasable memory means the memories that we cannot change the content. Now for the random access memory or read-write memories, the organization is the key design. Organization means how the bits are arranged inside this memory, and of course this will affect the speed of reading and writing the data. We'll move to the memory hierarchy. Let us see first this figure. This figure shows the memory hierarchy. So as you see, at the top of this hierarchy we have the registers, then the cache memory, then the main memory, then the magnetic disks and optical disks, and at the last is the magnetic tape. So the top three memories are internal memories, and the other is external of the computer. And the top, if we move from the top to bottom, so for the capacity, for example, the size will come bigger. So the register is very small memory, then the cache is bigger than register, then the main memory is bigger than the cache, etc. So if we move this hierarchy from the top to bottom, so the size will move from smaller to greater or to bigger capacity. And if we move from top to bottom also, the access time, and we can say the access time is the speed of reading and writing the memory. So we are moving from faster memory to slower memory. So the fastest memory is the registers, which are placed inside the CPU, then the cache, then the main memory, etc. Now for the cost per bit, also if we move from the top to bottom, we are moving from greater cost to the smaller cost, or from expensive to cheaper. So the register is the most expensive memory type. So when we select the memory, whether we select the registers or cache or memory or main memory, so we have to trade off means we have to do some balance. So it depends on what we need. If we need fast memory, so we have to pay more, and if we need more capacity, it will be slower. Greater capacity means it will be slower access time. So we need to select the memory based on what we need exactly. If we need faster and smaller, then register or cache or main memory, etc. Again, for the memory characteristic, we have two important characteristics of memory. First, the capacity, which is the size, then the performance. The capacity is how many bytes or kilobytes or megabytes, etc. of data can be stored in the memory. And the second is the performance. Now, what are the parameters? How we can measure the performance? So we have three parameters that we can use to measure the performance of the memory. The first parameter is the access time or latency. So what's the access time? Is the time it takes to perform a read or write operation to the memory or from the memory. The second parameter is the memory cycle time. The memory cycle time is the access time, the first one, plus any additional time required before the accessing the second read or write. So between the read and write and another read and write, there is some time delay, so this is called additional time. And if we add this additional time to the access time, then it's called the memory cycle time. The third parameter is the transfer rate. So what's the rate the data will be transferred to and out of the memory is the third parameter of the memory performance. Method of accessing data. Now if you have a memory, so how we can access the data of the memory, how we can read and write the memory, we have three methods. The first method is called sequential access, the second is direct, and the third is random access. The example on the sequential access is the tape. So the tape, we cannot go and read some data in the middle or at the end without reading all the data before that location. So we cannot go to the location directly, so we have to read it in sequential or in linear sequence to get to our data. And the time for accessing the data is variable. Variable means reading the data, or the time, access time for reading the data of location in the tape is different than the access time for another location. So if we read from the beginning of the tape, is different in the access time than reading some data from the middle or from the end of the tape. The second method is the direct access. Direct access, that we can access the location of the data directly but there are some time to reach to that data. So for example, on the CD, we need some time to seek or find the location of the data, then we can read it directly. And again, the text time here is variable because it depends on the location of the read-write head. If the data is near the read-write head, then text time will be small. If the data is away from the read-write head, it will take more time to access the data. And the example here is the disks. Disks are direct access. The third type is random access. Random access, that we can read any location directly without reading the locations before, like the main memory. The main memory has address for each location. If we know the location, then we can go and read the data directly from the memory. And in this case, the access time are equal for any location, are equal. So to access time from location 1 is the same as the time we need to access from location 1000. The main memory and cache memory are example of the random access memory. So the main memory, cache memory are random access memory, disks are direct access memory, tapes are sequential access memory. External memory will take forms also. So the external memory, either it is magnetic disk or optical memory or magnetic tape. So we'll go through these one by one. So the first is the magnetic disk. The magnetic disk, non-magnetic circular platter coated with magnetizable material. The hard disk drive is an example of magnetic disk. Now, how the hard disk drive or the magnetic disk drive structured. So the hard disk, for example, is a collection of platters. So we have platter, you see this is a platter, and each platter has double service. So we have the top service and the bottom service for each platter. So this circular diagram shows the service, how the service is structured. So the service, each service is what made of something called tracks. You see the circle, this one, this is a track, this is another track, and here is another track. So the track is this circular track, and each track is made of something called sectors. So for example, this track, as we have sector 1, sector 2, sector 3, sector 4, 5, 6, etc. And the data will be stored on the sector. So we can read and write sectors from the hard disk drive. So the read-write head, this is the read-write head in this figure. You see this is the read-write head. So we have one read-write head for each service. So for each platter we have two read-write head, one from the top and one from the bottom, to read the data from the service. So it means in each disk, in each service, there are thousands of tracks. In this example we have 1, 2, 3 tracks, but actually the service, each service has thousands of tracks. Then the track has hundreds of sectors. This track is made of sectors and hundreds of sectors, and also the data will be transferred in sectors, so we can read and write one sector at a time. So based on this information, we can calculate the capacity, the track capacity. So this is a track, for example. If we know the capacity of the sector, then how we calculate the capacity of track? So we multiply the number of sectors per track by the sector capacity. So by this way we can calculate the track capacity. To calculate the service, the whole service capacity, so it is the number of tracks per service times the track capacity, which calculated here. Then we can calculate the whole disk capacity by multiplying the number of services, how many services, multiplied by the service capacity. And in this case, this disk is called double side disk. So we can say the number of services here is the number of platters, how many platter, multiplied by 2, because there are 2 services for each platter. So by this way we can calculate the disk capacity. The magnetic disk has different characteristics or types or categories. Some of the disks are non-removable. Non-removable means mounted inside the computer, or removable disks that can be removed and replaced by another disk. And also we have double-sided disks or single-side. So the double-side means we can use the both sides of platters, not one single side, and each side of the platter called surface. For the read-write head, the magnetic disk has either fixed head or movable head disk. If it's a fixed head, it means we use one read-write head per track. Like in this figure, you see there is one read-write head for each track. And the movable disk, like here, so it is, we have one read-write head, and this read-write head has arm and can extend, move backward and forward to read or to access that each track. So the fixed head disk in this case will be faster than the movable head. For the hard disk or the magnetic disk performance, we have some parameters. We can measure the performance of the hard disk. So the first parameter is the seek time, and the seek time means the time it takes to position the read-write head at the track. So for this one here, the movable head disk, so this read-write head will move backward and forward to access the track. So this time it takes to position the read-write head to the track is called the seek time. Then the second parameter is called rotational delay, which means the time it takes for the beginning of the sector to reach the head, because we are reading from the sector, we are reading the data in sectors, so we need to access the correct sector. So the time it takes to rotate the disk to access the sector is called rotational delay. Then the third parameter is called access time. Access time is the total of the seek time plus the rotational time together, it's called access time. And the fourth parameter is the transfer time, the time required for transferring data from the sector. Now we come to the second type of external memory, which is the optical disk. And the optical disk has many versions or types. So we have CD, CD-ROM, CDR, CDRW, DVD, DVD-R, DVD-RW, or Blu-ray DVD. So the CD, the compact disc, can store up to 650 or up less than 700 megabytes. The DVD can store around 17 gigabytes maximum. Then the Blu-ray can store 25 gigabytes. So first, they are different in sizes, different capacities. And the second is we have some differences between, for example, the CD-ROM, CDR, and CDRW. For example, the CDR is called recordable CD, so we can record only once, and we cannot delete the content. CDRW, that it's called rewritable, that we can rewrite, erase the content and write again on the disk. Then the difference between the CD and the DVD is in the size. So the DVD can store more size, more capacity than the CD. And the last type is the Blu-ray, which is the new type of optical disc. The Blu-ray DVD is a high definition video disc, so it's used for the high quality video, and also the size can store up to 25 gigabytes. CD operation means the reading. What's the operation that we can use? The CD or the any memory has two operations, either read or write. Either we read or write. So on the CD, the laser will be used to read and write or burn the data on the CD. And the CD and the laser will use the idea of land and bit to read the data from the CD. Here's again the difference between the CDR and the CDRW. The main difference between these CDR and CDRW, the CD is recordable only, so we can write once only, and the CDR is repeatedly, so we can read and write, we can delete, we can erase the content and write a new data again. So the CD normally could be used for providing or for creating fixed data. So data, for example, to be distributed among people, so we can use the CDR to store a data, permanent data, that we don't need to change the content later. But the CDRW could be used to rewrite, to delete the data and write again. And there are some disadvantages and advantages for using the CDR. For example, the advantage is that we can rewrite, we can delete, we can erase the content and write again. The disadvantage is that the material that the CDRW made of, it will be eventually loses its property because we are reading and writing many times. The CD-ROM and DVD-ROM, CD in general and DVD, they are looks same from outside, but from inside it is made in different way. So for example, the CD-ROM has limited layers that we can read, one layer that we can read and write the data on, where the DVD has many layers and many sites. This is why the DVD can store more capacity, 17 gigabytes, but the CD is less than 700 megabytes. Finally, the magnetic tape, which is the third type of the external device. The tapes are made from flexible polyester coated with magnetizable material. The magnetic tape is sequential access memory, so we can access the data sequentially or in linear sequence from the beginning to the end. And the data here will be structured as parallel track or long track. From the beginning of the tape to the end of the tape, it will be parallel tracks, not like the magnetic disc. The magnetic disc, the tracks will be circular. The recording or reading from the magnetic tape, it will be as a form of records. So the unit of transfer here will be the records. So every time you can read block of records and write block of records. So this is the tape, and normally the magnetic tape will be used for the backup copies of the data. This is the end of lecture 7. And now please you can answer the questions of tutorial 7, and later you can discuss your answers with your lecture. Thank you for now, and see you in the next lecture.